Hey, it's Jillian, and we're going to take a look at functions and relations. So, what is a relation? Well, a relation is really just a short form for the word relationship, which you know long before you ever took a math class what a relationship is. It's the connection between two things, right? You and your parents have a relationship. Or actually, let me just do one to one. You and your mother or father or guardian or brother or sister or aunt or uncle or teacher all have you and they, each one separately, you have your own relationship with them. So, what a relation is the relationship between two variables. So, an x and a y. The relationship between x and y is a relation. And a function is a specific kind of relationship. So let's write this down. What is a relation? So it is the relationship between two variables. So we often use x and y, so let's just say x and y. And a relation can appear as an equation, a set of ordered pairs, or as a graph. So here we know that these are all equations that tell us the relationship between x and y. For example, y is, if you take x and you square it, you have y. So that's the relationship between x and y. X is x and y is x squared. So you could put this, normally we put a point in general, we say x, y, but in this case, we could actually call it x squared because y is equal to x squared, right? So the first value is x and the second value is x squared. Then we have this. You might not know what it looks like. It actually looks like this. This is a parabola this way. And when we have a parabola opening up this way, it's the swap of x and y. X equals y squared. And then, of course, this we know is a line. Y equals mx plus b, y-intercept 3, slope is 2, or 2 over 1. And the relationship between x and y here is whatever x is, you multiply it by 2, and then you add 3. That is what y equals. Here we have a set of ordered pairs. So here we have a bunch of x's, and we have a bunch of y's. Same thing, a bunch of x's, and then a bunch of y's. And here we have a graph that shows the relationship between x and y. So when x is 2, y is, looks like 1.5 or negative 1.5. And again, we're just approximating. So now let's talk about what a function is. I told you that a function is a specific kind of relation. And a function is a relation. And what's specific about a function is that for every x value, there is only one y value. So for every x value, there's only one y value. So how do we determine whether or not that any relation is actually a function? Since functions may appear in many forms, we have to discuss the method for recognizing them in these three forms: ordered pairs, graphs, and equations. So first with ordered pairs. Here, do we see that this x has only one y value? So for example, when x is negative 1, y is 3. Is there any other x value of negative 1 that has a different y value? No. How about 3? Is there only one 3 with a 5? Yes. Is there only one 6? Yes. Is there only one 8 in this group? Yes. So this is a function. I'm going to write F for function, and if it's not a function, I'm just going to write R for relation. So what would a set of ordered pairs look like if it wasn't a function? Okay, well, we have our set notation, so I'm going to do this. So So this is a relation because when x is -1, we don't only have one y value. We have, when x is -1, we have y is 3, and when x is -1, we also have y is 5. So this would be a relation, not a function. Now let's take a look at a graph. So with a graph, we know that if we draw a vertical line through x equaling, let's say, -2, that all of these points have the x value of -2, right? In fact, the equation of this line is x equals -2. Now, when we draw a vertical line, if we only cut our graph once, then that means that there's only one place where x has a point or where x has a y value. So in other words, when you draw a vertical line throughout your graph, if each vertical line only cuts your graph in one place, then you have a function. So what would an example of that look like if it was a relation? Here we go. When we do a vertical line here, we cut the graph in more than one spot. So this would not be a function, this would be a relation, because the vertical line, we call it the vertical line test, fails. It cuts it in more than one spot. So vertical line test is what we do to see if we have a function or a relation when we have a graph. Then we have equations. So equations are a tiny bit more work than ordered pairs and graphs, in that you have to be able to envision and plug a bunch of points in, or you need to be able to envision what the graph looks like. So I know, for example, that this graph looks like this. So if you know what the graph looks like, plot it. If you don't know, you can make some ordered pairs, plug in x is -3, -2, -1, 0, 1, 2, 3, and graph it, and then do the vertical line test. So I see that this graph has 2 branches, but no matter where I cut a vertical line, I still only touch my graph in one place. Or another thing I could do is I could make a list of ordered pairs. So when x is -3, y is -4/3. When x is -2, y is -4/2 or -2. When x is -1, I have -4. I'm just plugging in x into 4/x and seeing. When x is 0, well, I know 4/0 doesn't exist. That's why we have this break in the line, which is another discussion. But you'll be able to see, you know what, no matter what I plug in for x, I'm only going to get one y value. And when you can plug any number in for x and get 1 or 0, in this case there was no solution when x is 0, but if you're not going to get 2 or 3 or 4 solutions every time you plug in an x value, then you're going to see that it is a function. So let's determine which of these relations are functions. So let's do this. So we talked about this. We know this. When x is 1, well, y could have been 1 or -1, right? Because 1 is 1 squared, but 1 is also -1 squared. So when x has more than one y value, it is not a function. Here, are all these x's different? No. When x is 3, y can be 6, but when x is 3, y is also -2, so that is not a function. Here, can x be anything? Yeah. And for every x value, will there be a different y value? Absolutely there will be. If you can't see it, then start plotting the points and making a graph, which you know looks like this. And you know that wherever you draw a vertical line, you're going to cut the graph only once, so it's a function. Alternatively, you can work through the algebra and just, or the arithmetic really, and just say, when x is 0, I have one y value. When x is 1, I'm only going to have one y value. When x is 2, and so on. Here, let's take a look at this, see if any x is repeated. Nope, they're all different, so that's a function. Here, any sort of oval or circular graph, of course, is always going to fail the vertical line test, so that's not a function. This is a line. As you can imagine, any line is going to be a function except one kind, right? No matter where you draw, if it's steep, flat, they're all going to be cut by the vertical line only once, each line. The only line that is not a function is a vertical line, like x equals 2 or x equals 5. So this is a line that has a y-intercept of -3 and then a slope of 2. So this is a function. Here, this is the graph. This is the graph y equals positive root x, and this is the graph y equals negative root x. So they're asking us to graph both at the same time, and that's going to fail the vertical line test. Again, you can plug in x values and see for yourself. We know from previous chapters in this course that this is the equation of a circle where the center is 0, 0, and the radius is 4, and every circle fails a vertical line test, so this is not a function, not a function. And then here, this is, I don't think you've learned this yet, but this is what y equals negative x cubed looks like. We'll talk about that another time, if not in this course, another one. And we will see when we draw our little vertical lines in that it passes the vertical line test, so this is a function. Okay, so now let's talk about domain and range. When we discuss x values and y values in a relation or in a function, the x values make up what is known as the domain, and the y values make up what is known as the range. I just remember alphabetical. X comes before y, and domain D comes before R. So x goes with domain and y goes with range. For a set of ordered pairs, the domain is simply the first element or number of each pair, while the range is the second. For a graph, the domain is the set of numbers included in the graph which lay along the horizontal x-axis, and the range are the y-axis values. And for an equation written for y in terms of x, such as y equals something where there's an x here, the domain is a set of all values where x is allowed to be, and the range is a set of all values that the y is allowed to be. So let's take a look and do some examples here. So the domain here, we have these 4 points. The domain is, this is the x value 1, this is the x value 2, this is the x value 3, and this is the x value 4. And the range, you make an S and then you reflect it like that. The range is, let's see, the y value of 3, 4, and 5. You don't write 3 twice, you just write down 3, 4, 5. Now let's take a look at this. When you had a graph with specific points, you just wrote down the values. But when you have a solid graph, that means we're going to use some inequalities. So for example, here, we can see that x is going to keep going forever in this direction. And as this goes here, it's going to continue forever in this direction. So the way we write it is x belongs to the set of real numbers. So what are real numbers? Real numbers are all numbers except wonky things like negatives under square roots, which right now we're saying don't exist, and they don't, but we get into something with that next year. The range, let's take a look at the range. You know, also your pencil might help as a sort of vertical line. Like you might say, okay, this just keeps going and going and going. So the x values keep going and going and going, and here the y values keep going and going. Sorry, the x values in the negative direction keep going, 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 so x can be any number. The range, we look at this way. So the y, it goes all the way up here, and then it starts, where does it start? The lowest y value is there at -1. So the y values are all -1 and greater. So y is greater than or equal to -1. And there's the range. Let's do the domain and range for this. So we've got 0, 1, 2. 0, 1, 2. And then range is 1, 1, 2, 1, 2. Just 1 and 2. 1 and 2. Here we have a line, so we know what this looks like. This is a line. This quick sketch here. The y-intercept is 1. Then we rise 2, run 1, and we have a line that goes forever in both directions. So there's no, these keep going in every direction, that way, this way, and up and down. So the domain is that x can be any real number, and the range is that y can be any real number. Okay, now let's take a look at this. Okay, we know this isn't a function, but we weren't asked if it's a function. We were asked to state the domain and range, so let's do that. So the domain, just do my little squiggly brackets, their proper name is set notation. So here we have x values along here that go as far as -3 and as big as 3. All the points here have x values somewhere between -3 and +3. -3 is less than or equal to x, which is less than or equal to 3, and we squiggle our bracket. Now, of course, the circle is the same all the way around, so of course from -3 to +3 will be the range as well. Now, sometimes, just to let you know, sometimes teachers will ask you to write more here with respect to this sort of stuff. We'll talk about that another time. Right now, I just want you to get the visual of where x and y values are. So here's a picture of another line, just like we had here. And we know for all lines that the domain is going to be x can be any real number, except vertical and horizontal ones, and the range will be y can be any real number. And that is domain and range and function and relation.